This video is for those who are working on a project and have found that they need to choose some soldering equipment. So basically somewhat inexperienced with soldering. So we're looking at picking soldering equipment that might be suitable for something like radio controlled cars and drones. And you'll find that you still need some capable equipment, something that can be temperature controlled and have tips of varying thermal mass. We're not going to look at surface mount rework of boards or anything that complicated. So what prompted this? As a retired engineer and instructor, I got my first 3D printer some time ago. And I've decided to build some RC cars. I'm currently working on one from 3D Sets called Sandy. And hopefully we'll move on to something a little more rugged like the Tarmo V4. I used to teach some high reliability soldering with thousands of dollars worth of equipment, but now I'm looking at something as low a cost as possible. And since I'm in Canada, I'll show you some equipment using Canadian dollars. So my purchase options are limited. I'm in rural Nova Scotia, so Amazon, AliExpress has a lot of low-cost equipment, and I'd like to go local, so various Canadian or North American distributors of soldering equipment if possible. So let's look at the setup that I sort of decided on. And what you can see here is a very small soldering workstation that I've set up, and this is some of the electronics in my car. And you can get a quick look at some of the stuff, and I'll go over this in an individual way. So the first thing though that I bought was a silicon mat for my workstation, and it was about 1.8 millimeters in thickness, I think, and that's high temperature, so if I spill solder on it, it's not going to leave a permanent mark or ruin my desktop. The next thing I had was and I'll stop this here, you really need something more than just a pencil soldering tip, and I tried to use a 25-watt soldering pencil. I made a mess of my first little project, so I decided to go with a low-cost soldering station. So this is a Weller 1010, and it was about $144 in Canadian dollars. The nice thing is it allows you to vary your temperature. If you have higher gauge wire, you'll need a little hotter temperature, and it comes with multiple tips, and I'll show that in a second. Very easy to use. This is in centigrade, 360 sort of a standard, but very easy to move up and down. And you'll see the button below has a menu option, so you can save some settings in there. The basic station, you'll notice here, I'm only using a sponge. I'm not using, I see today there are brass balls that you can poke your iron in, and I have no experience using brass. I know brass is fairly soft as a fabric. I would worry about it taking the coating off your soldering tip, so that's one little thing you want to be concerned about. One thing you should always do with your soldering tip before you put it away is coat it with solder. It will smoke a little bit, but leave that. That will protect it from oxidizing. And you'll notice so this is just a showing of the tip here. Now this is a fairly small thermal mass tip. And if you buy a soldering pencil, and that's just shocking the tip before you use it, it gets off the oxides. And then you would make your solder joint. Now here's another tip I've purchased, and you'll notice this is quite a bit thicker. And the reason for that was over here with my 25-watt soldering. I made quite a mess of this. This was a speed controller that I changed the connector on, and I had to put a different connector called a Dean's T connector. And I couldn't get it hot enough with the tip and the 25-watt pencil iron I had. So that shows the need for different thermal masses. For heavier gauge wire, you want a larger tip and a slightly higher temperature to make the joint proper. Now there's some other things you'll also need. Now it doesn't say it here, but this is Eutectic solder, and that is 6337. So you'll find it's 63% tin and 37% lead. And that has a melting temperature of 361 degrees Fahrenheit, and that's the easiest to use for rework. What I have there shown is about 1.25 millimeters or 0.05 inches in thickness, and that's sort of an average gauge. That works pretty well for most things unless you're working really fine, but it should work fairly well even for 16, 18 gauge wire. Now you don't need a lot of solder. I had a spool lying around, but you can certainly buy smaller amounts in a whole spool. Inside of solder, solder's hollow, and inside is some flux, and flux is really important for getting rid of or sort of cleaning your connection and making the solder flow. I have old solder, and for large connections you may need additional flux or rosin. You can buy this in a liquid form. I just find the liquid form sometimes gets a little messy, so I'm going to try this paste flux. I haven't tried this before, but for any soldering it really helps to have a little bit of flux, either liquid or in some form, available for those connections which may have some oxide on them. You may need to clean them, and they'll certainly make the solder flow better as well. Now, when cleaning and getting rid of the flux that will inherently be in any connection, you want to look at using isopropyl alcohol. But if you'll notice there, you want 99% alcohol, not the normal 70% that you can get sort of at Walmart. You can get 99% isopropyl alcohol almost at any drugstore. And to clean it, you want something that's lint-free. We've always used what are called Kim wipes. There may be something special. It's a little more abrasive, but it doesn't have any lint inherent in paper towels. Now, one of the things I didn't mention here, you'll see in the background I have a little fan in my window, and these are exhaust fans, so they're drawing the air out. You get molten lead here, so it's good to have some type of exhaust. I just have a cheap fan close to a window, but you shouldn't be breathing in soldering fumes for any length of time. The other safety concern is with solder itself. It's lead based, so you want to make sure that after you handle solder, you always wash your hands really well. Now you're going to need something as a vise, and here's a couple that I made. You'll notice this is fairly good for holding wires. This was made out of PETG, so this just simulates a wire that you'd put in one end. And I think this will work fairly well. I haven't actually used it yet for soldering two wires together. Now you can't put anything in there that's too hot, or else you'll melt the PETG. There's also small clamps that you can make as well, but these are all plastic. And you can see some clamps can be clamped on there. I've got my motor held with a clamped on clamp that you can attach to your workbench. There are certainly better clamps that you'll probably need to purchase. We'll take a look at a couple. The standard that I've used in the past are Pan of Ice. This has jaws which are nylon. They can withstand a bit more heat, I think up to about 200 degrees Fahrenheit, but if you were soldering a metal connector right into there, you may melt the nylon. And it comes in a base and a standard head. A little expensive here, but very robust. You'd only buy that once. AliExpress have cheaper versions. This will only open about 30 millimeters, but it's all metal. And if I have to connect some bullet connectors, so the metal has to go have to connect directly to metal, so this will be a little better. It's made out of aluminum. It also has a vacuum base, and I think these are only $20 from AliExpress. Other things you'll need are some heat shrinking tube, and you can buy loads of this from AliExpress of different diameters. It will shrink depending on the heat shrink tube, 2 times smaller or up to 4 times smaller. So you want to get some small segments of different diameters. These are very important for the aging project. I have a 3.25x, and you can get different types of goggles for use for different projects. So that's just an overview of some of the equipment that I've gotten. Maybe that might help in your selection. Best of luck on your projects.